A very good day to all. So, in today's lecture series, we'll be discussing about the mechanical working of metals. So, this topic is in continuation with metal forming process. So, already discussed in the metal forming process, the first basic stage is creating a metal, which may be an alloy or a pure material. So, that metal has to be made into certain shape to be used. So there are various methods for making the metal into required shape. So first one is casting. Second one is welding. And the third process is metal working process. So this metal working process is one of the most important process in mechanical manufacturing of metals. Metal working plays a major role in manufacturing of metals. So whichever metal you see around you, maybe it may be the metal chair in which you are sitting, or the metal bed you are using, or the metal table you are using. Every material in that particular object will be made up of mechanically worked metals. So why we are using such mechanically worked materials? Then cast parts can be comparatively lower cost compared to mechanically worked metals. So why we are going for mechanically worked metals? That's what we'll be studying in this topic. The importance of this topic is to understand why we are mechanically working the metals. The first part is what is mechanical working. So mechanical working is nothing but we are intentionally deforming the metal. So what it indicates is that imagine your body, you are preparing for a running race. So what you will do in the beginning, any sport you take, before going into the sport, what you will do is you will first get warm up. You will do warm ups, and then you will begin your workout, and you will train for a certain period of time. So then only you will go for actual match. So imagine it is the same case for even for cricket or any sport. You will first practice and then you will get into the match. Similarly, metal will be intentionally deformed before actually utilizing it for manufacturing. So why we are doing that is to impart certain internal forces. So there are two ways by which internal force can be imparted. One is hot working and another one is cold working. So this is a process of the metalworking process. So getting back, why we are doing this metal working? To take a metal which is a cast material and you observe it under the microscope, there will be globules of metals. So metals will always be linked with another material. One atom will be linked with another atom, and they will form a bond, and they will be in the form of globules, small rounds. So those are called as grains. So when you see a cast material under a microscope, the grains will be scattered and will be very large in size, and there will be gaps in between one grain and another. So when you compare it to the sand, a clay is a closely packed material, whereas your river sand or your desert sand is a loosely packed material, which has more weight retention capacity. If you place a load on a clay and load on a desert sand, which will which will retain the weight. So if you keep it in a sand, it will be sunk instantaneously. Whereas if we keep it in a clay, for a certain amount, it will be able to withstand the load. That indicates that in the clay, grains are closely packed, whereas in your river sand, the grains are loosely packed. Same case with the metal. When you impart load on a cast object, an object which is made using casting, it will break. When you impart a sudden load, shock load on a cast object, it will break. Whereas in the metal worked process, what they are doing is they will be applying load on the cast object. They will be heating it to a certain temperature. So that temperature is called as recrystallization temperature. So temperature at which new grains are formed. So that temperature is called as recrystallization temperatures. So what happens at this recrystallization temperature is that the grains will break away and new grains will be formed which are smaller in size. So as you can see here in this image, so they are working the metal above the recrystallization temperature. So what happens is, as you can see, once the roller passes through the material, the new dense grains are formed, whereas before they are very large grains. So what these small dense grains indicate is that they have more strength compared to previous larger grains. So new grains are formed only only the metal is worked above the recrystallization temperature. So the melting point of steel is around 1400 degrees Celsius. So recrystallization temperature for steel is around 753 degrees Celsius. So at that temperature, recrystallization or formation of new grain takes place. So that is hot working process. So whereas if we go for the cold working process, here the material is deformed below the recrystallization temperature. So here no new grains are formed, but already existing grains are stretched and they are compacted together. As you can see here, they are elongated and compacted together. So this leaves some stress inside the material. So those stresses are called as residual stresses. So what this residual stress does is it improves the strength of the material. So that's the difference between hot working and cold working. So in the hot working, since new grains are formed, there will be no residual stress. Whereas in cold working, since it is done below the recrystallization temperature, the material will be deformed, the grains will be deformed, and it will be elongated, and there will be a stress developed inside the material, which is called as residual stress. So what this residual stress does is it improves the surface finish of the material. So that compared to hot working and cold working, the materials which are produced using cold working has greater surface finish when compared to hard working materials, but hard working materials will possess lower residual stresses. So what sometimes this residual stress does is they may create some cracks, internal cracks may be developed. So those cracks may lead to eventual failure, but in hard working, no such cracks are formed, and hence deformation, chance of sudden failure is lower. So that's the difference between this hard working and cold working. So what are the different processes by which hard working and cold working are done is a topic for next presentation. So I hope you understood this topic. To give you a quick recap, today we discussed about hot working and cold working process. So hot working is a process which is done above the recrystallization temperature, that is the temperature at which new grains are formed. Whereas cold working is a process which is done below the recrystallization temperature. So I hope you understood today's lecture. We'll see in yet another topic. Thank you.